Hello students, myself Dr. J.P. Sridhar, Associate Professor, Department of Electrical Engineering, SJB80. Today I am going to start the analog filter design. In that I will discuss how to design the analog filter, especially in that I am deriving the equation for order of the filter n. Let us consider the question. It goes like this: to find the order of the filter n and cutoff frequency omega c for a Butterworth filter. So before starting the derivation, let us see the magnitude squared response of the low pass Butterworth filter is written here. This is the magnitude response curve of the low pass Butterworth filter. So for any filter design, we will have the four specifications as we discussed. So one is analog frequency. In analog frequency will be the pass band frequency as well as stop band frequency as well as gain. Gain and frequency are the two components, important components required to design any filter. Okay. So before derive the equation for n, we should write the magnitude squared response of the low pass Butterworth filter and mark all the specifications. So we will have K1, K2, omega 1, omega t. Some of the textbook they will take K1 as Kp and K2 as Ks. Okay, and omega 1 as omega p and omega 2 as omega s. Now what is K1? K1 is attenuation in pass band gain. Omega 1 or omega p is pass band edge frequency. K2 or Ks is attenuation in stop band or stop band gain, and omega 2 and omega s is known as stop band edge frequency. So once you know K1, K2, omega 1, omega 2, mark all the specifications in the magnitude squared response. Okay, then continue the procedure. Then we should know the magnitude squared response of the low pass Butterworth filter is given by h of j omega square is equal to 1 divided by 1 plus omega by omega c whole power 2n, where n is the order of the filter. We are going to derive the equation for n in this derivation. Now it is in power 1 plus omega by omega c whole power 2n, where omega is the frequency, analog frequency, where omega c is the cutoff frequency. We are deriving the equation for both n as well as omega c in this class. Now what we can continue with the derivation part is, now collect as equation 1. Now let us put omega is equal to omega 1 and h of j omega is equal to k1 in the equation 1. Then the equation 1 becomes, so put it omega is equal to omega 1 here. Wherever omega is there, replace that omega by omega 1 and this h of j omega by k1. So we will get magnitude of k1 square is equal to 1 plus 1 divided by 1 plus omega is omega 1 divided by omega c whole power 2n. Now we will take this term to LHS and automatically this term will come to the denominator. You will get this equation 1 plus omega 1 by omega c whole power 2n is equal to 1 divided by magnitude of k1 square. Now I will keep omega 1 by omega c whole power 2n and I will bring this 1 to RHS. I can rewrite this equation as omega 1 by omega c is equal to 1 divided by magnitude of k1 square minus 1. I already know that this k should be here, it is a constant, but to derive I will consider k should be in decibel. So I will consider the constant k1. I will take this and I will find out the decimal value of that. Okay, so k should be in dB means I will take the logarithmic of that constant, so 20 log of that k, then k dB, and this 20 will come to the denominator. You will get k dB divided by 20 is equal to log k. So you bring this log to left side, you will get k is equal to anti-log of that k by 20 dB. So I am finding the equation here. You can see here I'll replace 1 by k1 square as 10 to the power of minus k1 by 10 or 10 to the power of minus kp by 10, as well as 1 by k2 square as 10 to the power of minus ks by 10 or 10 to the power of minus k2 by 10. I'll replace 1 by k1 square as 10 to the power of minus k1 by 10 minus 1. Call it as equation 1. This is equation 2. Similarly, we can let us look at here. I will take omega is equal to omega 1. I also will get equation 2. Similarly, in equation 1, put omega is equal to omega 2 and h of j omega is equal to k2. Then simplify the same in the above procedure. I will get omega 2 by omega c whole power 2n is equal to 10 to the power of minus k2 by 10 minus 1. What are the changes? So, omega 1 is k1, omega 2 is k2, and both k1 and k2 both are gains that should be in dB and both are negative. So, you can keep it in mind, the gain is always negative. If in the problem the gain is given positive also, while simplify you can assume the gain should be negative value. Once you can find equation 2 and equation 3, what we can do, dividing equation 2 by equation 3. So, what is equation 2? Omega 1 by omega c whole power 2n divided by omega 2 by omega c whole power 2n is equal to 10 to the power of minus k1 by 10 minus 1 whole divided by 10 to the power of minus k2 by 10 minus 1. Omega c will get cancelled. So, we will get omega 1 by omega 2 whole power 2n is equal to 10 to the power of minus k1 by 10 minus 1 divided by 10 to the power of minus k2 by 10. I will get this equation. Now, I am deriving the equation for n. This n is in power. So, now we can simplify that. Look at here. Now, I will take this power to a constant. So, automatically you get the log value 2n to the base log of to the base 10 is omega 1 by omega 2 is equal to log to the base 10 of 10 to the power of minus k1 by 10 minus 1 minus divided by 10 to the power of minus k2 by 10 minus 1. Then you need n value, keep n value as it is, and 2 and log to the base 10 will send to the denominator. You will get n is equal to log to the base 10 of 10 to the power of minus k1 by 10 minus 1 divided by 10 to the power of minus k2 by 10 minus 1 whole divided by 2 log to the base 10 of omega 1 by omega 2. So, in this equation, so you keep n and remaining part is 2 log entire term will send to the denominator, you will get equation 4. So, equation 4 is the expression for find the order of the filter n for the low pass Butterworth filter. And one thing you can keep it in mind, always you can choose n is always not an integer value. Whenever n is not an integer value, you can choose always the higher value for the design of the low pass filter. Suppose if you get n is equal to 2.3, you can choose n is equal to 3. Don't select n is equal to 2, because whenever you get any non-integer value, you can choose always n with the higher value, okay, and round up to the next integer value. Suppose you will get n is equal to 2.01 also, we can consider n as 3. Don't take 2.01 as 2, okay. If it is 001 also, you can choose always n the higher value of n. So, equation 4 will give the expression for the order of the filter. In exam, they will ask, okay, derive the order of the filter n and cutoff frequency omega c for the given low pass Butterworth filter. You have to derive this equation. Once we derive the order of the filter n, we can go to the cutoff frequency omega c. What is cutoff frequency? Cutoff frequency is omega c. How to derive cutoff frequency? Let us see here. Consider equation 2. What is equation 2? Omega 1 by omega c whole power 2n is equal to 10 to the power of minus k1 by 10 minus 1. So, you required omega c. Keep that omega c as it is and bring this to LHS and this omega c to RHS. Automatically, you will get omega c whole power 2n is equal to omega 1 whole power 2n divided by 10 to the power of minus k1 by 10 minus 1. So, Again replace, I will simplify once again. I will bring this 10 to the power of minus k1 by 10 minus 1 to LHS and this to the denominator. So I will get omega 1 by omega c whole power 2n is equal to 10 to the power of minus k1 by 10 minus 1. So this 2n will get cancelled. So the remaining is omega 1 by omega c, which is equal to 10 to the power of minus k1 by 10 minus 1. But I required only omega c. So what I will do, I will bring this to denominator. So omega c is nothing but omega c1 is equal to omega 1 divided by 10 to the power of minus k1 by 10 minus 1 whole divided by 1 by 2n. Similarly, if you replace omega c as omega c1 and similarly you will get omega c as omega c2, so we will get omega 2 divided by 10 to the power of minus k2 by 10 minus 1 whole power tn. Then what is my cutoff frequency? Omega c equals omega c1 plus omega c2 divided by 2. This is the cutoff frequency omega c for the given low pass Butterworth filter. So this is very important question in examination. They will ask for 8 to 10 marks. Derive the order n and cutoff frequency omega c for the low pass Butterworth filter. You derive both n. What is n? N is log to the base 10 of 10 to the power of minus k1 by 10 minus 1 divided by 10 to the power of minus k2 by 10 minus 1 whole divided by 2 log to the base 10 of omega 1 by omega 2. That is the derivation for n, and cutoff frequency omega c is omega c1, which is equal to omega 1 divided by 10 to the power of minus k1 by 10 minus 1 whole divided by 1 by 2n. So sometimes in exam, okay, they will ask either only n or only cutoff frequency. You should know how to derive the equation for both. So with this I will conclude.